Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 11C assignment. First one we're going to take a look at is number 1. Write down the intervals where the graphs are increasing and decreasing. So let's do this. Increasing and decreasing for A here. So this one here is always going up. So this one is always increasing. There's no decreasing section in here. And it's increasing. Let's see, we don't care about the y value, we just care about the x value. So if we do our little start and end idea here, that should make this pretty nice and easy. Put x in the middle. Where does this thing start increasing? When x equals 0. When does this stop increasing? It's got an arrow on the end of it, so it doesn't. And then we always just put, if it doesn't have an end or a beginning, you just leave it blank, right? And then we just always put a greater than sign. Well, actually less than, sorry. The 0 is less than x. Well, so this means it's increasing when x is greater than 0, right? Or actually, since it's a solid dot, we can put x is greater than or equal to 0. And that's the one spot where it's increasing as long as x is greater than or equal to 0. We don't know what happens if x is less than 0. Okay. For E, let's do this. Increase and decrease. So always reading left to right. This thing is decreasing right in this section here, and then it's increasing, and then it's decreasing. So we've got 2 spots where it's decreasing and 1 spot where it's increasing. So if we do start, where does it start and when does it stop? Start, stop, or start, end, whichever one you want to do. Put x in the middle there. We've got 2 for decreasing and 1 for increasing. So let's start with the one on the left. So where does this thing start decreasing? It doesn't have a beginning because it's got the arrow that goes forever and ever, so we leave that blank. Where does it stop decreasing? When x is 1. Right? So we just do a less than. So it's decreasing when x is less than 1. Yep, so everything over here, as you're reading left to right, it's always going down when x is less than 1. And then the next one here, it's increasing. So where does it start increasing? When x is 1. Where does it stop increasing? When x is 5. And then we put the less than signs in there. So it is increasing when x is greater than 1 but less than 5. So x is greater than 1 but less than 5, that's increasing. Okay, and then this last one's decreasing. Where does it start decreasing? When x is 5. Where does it stop decreasing? It doesn't. It's got an arrow. It goes forever and ever, so we just leave that blank. And we do the one inequality, and there's our answer there. It's increasing when x is between 1 and 5, and it's decreasing when x is less than 1, or when x is greater than 5. Okay. For H, let's see, we've got increasing, decreasing, increasing, decreasing. Right? So we've got 2 increase, and we got 2 decrease. So start and stop. And we'll put x's in the middle here. And we know we've got 2 of each, 2 increase, 2 decrease. So we've got a bunch of x's in there. Anyway, starting with the far left, that one's increasing. Where does it start increasing? It doesn't have a beginning, so we leave that blank because it goes forever and ever. Okay, and then it stops increasing when x here, don't give us a coordinate, but we know that that's the origin, so we know that x is 0. So it's increasing when x is less than 0, right? So anything over here, as we're moving left to right, this graph's going up. Okay. Next part there is decreasing. It starts decreasing when x is 0, and then it stops decreasing when x is 2. Put our less than signs in between there. When x is greater than 0 or less than 2, which is this area right in here, it's decreasing. Next one's increasing. It starts increasing at 2, and then it stops increasing when x is 6. Put our inequalities in between there. And then, so again, it's increasing when x is greater than 2, but less than 6. Okay, and then the last one, where does this thing start decreasing? It starts decreasing when x is 6. And then it doesn't have a spot where it stops decreasing. It decreases forever and ever after that. So then we just put our one inequality in there. And here's our answer there. Okay. This last one, it's decreasing as long as x is greater than 6. So as long as x is bigger than 6, this graph is going down. Okay? Okay. All right, find the intervals where f of x is increasing or decreasing. So now they don't give us graphs. We actually have to come up with our own graphs. So that's where we're just going to want to bring up our graphing calculator. Or you can even do this on Desmos. But remember, test time, you will have to do this with a graphing calculator. So you probably want to get familiar with how to do it on here. So f of x equals 2x plus 1. So if we simply put in 2x plus 1 and we hit our graph, this thing is just a constant straight line going up forever and ever. So find out where the intervals are. This entire graph is increasing. So it's increasing for all real numbers. That's all you have to put in for that. Okay, so increasing, and there's no spot on this graph at all where it was decreasing. Okay, so let's try the second one. So we'll do y equals, and now we'll do negative x squared, and then we'll delete that thing. No, x cubed to the third. I think that, oh no, I might have messed that up. Let's try that again. Negative x to the third power. There we go. Okay, and we hit graph, and here's what our graph's going to look like. It's going to start. It's going to come down here, and there's our little spot there. So really, this thing is decreasing all the way until you get to 0, and there's a weird little spot there where it's just where the tangent there is going to be 0. So it's really not increasing or decreasing there, and then it's decreasing again. Okay. So really this thing is decreasing at all points here, so we can just do this decreasing for all real numbers. That graph is always decreasing. Okay? Okay, let's look at one last one, and we'll call it good. For each of the following functions, find f prime of x. Use technology to find the values of x for which f of x equals 0. And then hence find the intervals where f of x is increasing or decreasing. Okay, so this is basically figuring out when this graph is increasing and decreasing without using the graphing calculator. We'll go through, show you how to do this, but you can always use your graphing calculator on this. Okay, so 3 times our derivative here, f prime of x. 3 times negative 4 is negative 12. X, 3 minus 1 is squared here. 2 times 15 is 30. X, subtract 1, and that's x to the first. That's x to the first right now. 1 times 18 is 18. Subtract 1, and the x's are gone, and the derivative constant is 0. So we found we found the derivative of x. Use technology to find the values of x for which f prime of x equals 0. Okay. So what that's having us do is they want us to put this into the, say, the graphing calculator is, one way to do this, and graph that thing. And then we want to find, so we want to find when f of x equals 0. So we want to find where these x-intercepts are. So we do second trace, which is calculate, and we want to find the zeros. Okay, so left bound, let's see, x is 0. I want to get this, here we go, we got to get this to the left before it crosses through the x-axis, enter. And then we also have to get it to the right after it's crossed through the x-axis. So that would work. And we push enter one more time, and negative 0.5. So when x equals negative 0.5, and you can also look on here and say, look, that's 1, 2, that's definitely going through at 3. So at negative point, oh, sorry, not negative 0.5. Oh, yeah, it is negative 0.5. Negative 0.5 and 3. are the values of x which it equals 0. So then it says, hence find the intervals where f of x is increasing or decreasing. Okay, so what we're getting at is we know that these two here are going to be maximums and minimums. Okay, now really, honestly, with this here, if I was doing this problem here, I'm just going to put this original equation in. Oops, that's not what we want. So let's just put the original equation in. Okay, so here's our function. We hit graph, and it's going to graph our original function here. And it's coming down, and it's got a minimum right there, and then it's going to have a maximum way up here. Guess what where that x value of the minimum is? Right there at negative 0.5. And then the x value of that maximum there is 3. Okay? So really what I would do, again, I wouldn't even bother with the derivative. Let's just put this thing in here, and then I'm going to sketch this graph. Looks something like that. We know that the x value of this minimum is negative 0.5. We don't even care about the y. We know the x value of this maximum is 3. We don't really care about the y. And so then now we can do our intervals. It says, hence find the intervals where f of x is increasing or decreasing. So this thing's decreasing, increasing, decreasing. So let's do this. Increase, decrease, and we'll do start. Let's do start and stop. We put our x in the middle, right? So first one is decreasing. Where does this thing start decreasing? It doesn't have a beginning because it's always decreasing until it gets up to negative 0.5, right? And since there's no beginning, we don't put anything for the start. X has got to be less than negative 0.5, and it's decreasing. Next part is increasing. So that starts increasing when x is negative 0.5, and it stops increasing when x is 3. Put our inequalities in there. And then the last one is decreasing. So we got another one here. Where does this thing start decreasing? When x is 3. Where does it stop decreasing? It doesn't. It's got an arrow. It goes forever and ever. So then there's our final answer there. It's increasing when x is greater than negative 0.5 and less than 3, and then it's decreasing when x is less than negative 0.5 or if x is greater than 3. Okay? Okay, that's all we have for the 11C problems. If you have any further questions, please feel free to ask. Thanks.